Hello guys and welcome to a new video. In our last video we discussed and learned about inheritance and the connection between the parent classes and the child classes. So after learning about inheritance, it's important to learn about a new concept similar to inheritance, and it's called abstraction. So abstraction, as the word is just self-explanatory, means that something unclear, something not yet completed. So this is the same as our classes. So whenever you create a class with the abstract keyword, it's not yet a complete class that you can use. So let's try this. So we go to the our developer class from our last video, and just it was annotated with open keyword, and you see that it's a complete class. You can create an instance of this class. Nothing is wrong with it. And if we try to create an instance, so dev equal to developer, and here we're just gonna pass empty lists. So list of false, and for example I'm gonna try to fix bug. I'm gonna call the functions, maybe print the drinks coffee, for example, drinks caffeine, I guess it's called. Yes, drinks caffeine. And we run the program. So as you can see, there's nothing wrong, no errors, everything works as it is. Everything is perfect, as this class is just a class, no matter if what was annotated with the open keyword or any other word. But notice here, when we add the abstract keyword, you see nothing happens within the class. But when we go to our instance, you see that there's an error saying that you cannot directly make an instance of a class or of an abstract class. So abstract classes are just meant to be parent for other classes, meant to be left as they are, meant to have no instance of the class. So abstract classes are just base of something, but you cannot build upon that base. So this is what abstraction means in short terms. That's great. Now let's go to maybe our child here, the Android dev. So Android dev has no problems. It works it doesn't have any errors, as we are still extending the developer class, which is an abstract class, and we also have these functions right here. So say for example, I'm just going to delete my functions here. We won't have any errors, everything works as before, because our functions here are annotated with the open keyword. So open keyword gives you an option to re-implement the functions, or just leave them as the default implementation in the parent class here. But once you declare them as abstract, then you should delete the body, because abstract function cannot be implemented within the same file. So the abstract here gives the option, forces you to delete the body on the parent class. I'm going to try this here as well. And lastly, for this guy, abstract. Now we go to the Android dev and see we have an error saying we have to implement the unimplemented methods. If you just over here and see class is not an abstract and does not implement abstract base class. So the base class, we have to implement the base members of that class, or the base members that were annotated with the abstract keyword. So here we just press implement members and we find the same three and we press OK. So they are implemented here. Nothing is wrong. The same syntax as before, override fun code, and so on for the other functions. Now we're just going to have any print statement. Choose whatever you want. Now let's go to our iOS developer. So the iOS developer here, we didn't implement any classes. So here it forces us again to implement, didn't implement any functions. So it forces us again to implement the functions. And here we're going to implement them. Great. So whenever you want to mark your functions as abstract, you leave the implementation for other classes or other child classes that extend your class. And if you, for example, want your function to have a default implementation, if any other child classes didn't implement it, you annotate it with open. Then you add the body and your implementation here. And lastly, if you don't want anyone to modify this function, you just add a normal function. What was the name? Yeah, helping devs, just a normal function. And here, nobody can extend it, nobody can modify the function. All of them will have access to the function, but none of them will modify it. So all of them can call the function. So for example, helping devs here, notice we don't have any keywords, and we get back, we make this Android developer instead of developer, and now dev dot helping dev, we are able to access it, but we cannot, and see we have an error here, we cannot override it and re-implement it, so we have to delete it. And also in the iOS, you cannot re-implement it in its final and cannot be overridden. So any function in Kotlin that wasn't annotated with open keyword or abstract keyword is marked with the final keyword. And see, it's redundant here, you don't have to add it because every function is final if it wasn't annotated with abstract or open. And yes, the final means it's immutable, so it's just the same as having a val name equal to something. You cannot modify name again, so name equal to another thing, and here we have an error saying it's immutable with the val. So final makes the function unchangeable. You cannot change it, you cannot extend it to re-implement it. That's the final here. A little note about abstract and open keyword. Whenever you have a class that marked with abstract and you want to make it open class to be extendable, this is redundant as abstract makes the class extendable, open makes the class extendable, but both have a different abilities or qualities that they give to the class. So open makes the class extendable and makes it a complete class. Abstract makes the class extendable and makes it an abstract class that is incomplete, that you cannot implement directly without having a child that you cannot have an instance of. So that's the difference between abstract and open. We have learned the difference between the abstract functions, the open functions, the regular functions, as well as the abstract classes, the open classes, and the regular classes. But we didn't discuss one thing, which is the abstract attributes or abstract properties. So say for example, you want to annotate your attributes with the abstract keyword. So we're going to make it in the constructor here like we did with the abstract, with the open keyword. And notice here we have an error saying that you cannot directly add the abstract in the constructor of the class. So for that, what you're going to do, just going to leave him as open, and whenever you want to have something abstract, you got to add here within the function or within the class body. So abstract, maybe meetings of type list of string. It must be a val or var, whatever you want. Var it works, and val it also works. Great. So notice here you don't have to add any values or initial values because it's an abstract, and if you delete the abstract, we're gonna have an error saying that you have to add must be initialized or abstract. So you're gonna add a default value, list of, for example. But when you annotate it with abstract, then the default value is not allowed here, so you're gonna delete it. Now let's go to our child classes. Here we see we have an error saying that we have to implement the meetings list of, because it's an abstract. So if you press implement as a constructor parameter, it's going to be added to the constructor here, just like the languages, which is an open. So languages is an open within our developer, it's an open. Tools and drinks caffeine as well. And here they are not annotated with the override because here they don't point to the same attribute. You can add them or you can leave them as before. Everything works, everything is fine. And the abstract here is implemented as an attribute or a property in our constructor here. If you go to our iOS class, same, we have to implement it here or within the body. So if you come to the body of the iOS developer class and press Ctrl O or Ctrl I, you would find it here, and you press OK. So now it's implemented as a member, or it's implemented within the body of the class. But here we have to add an initial value because it's an abstract and you cannot just leave it as an abstract. You have to add an initial value if you override it. So for that, I'm going to just have it list up. So this is the difference between implementing the abstract property within the body and within the constructor. So within the constructor, you don't have to add anything. Within the body, you are supposed to add a default value. Now let's discuss the last thing for this video, which is the visibility modifiers. So the visibility modifiers is just a keyword that you add before your functions or attributes, so before your members in general. So say for instance, I'm going to have a val here within our parent class, the developer class. Val is called my profession and is going to equal to I am a developer. Now we don't annotate this with anything, so whenever we go to the Android developer, for example, and within the code function, I'm just going to print my profession. See, we have an access to it in our subclass, my profession here, which is this one here. It wasn't annotated with anything. If we go to our main activity, our main class, we have created this instance of Android developer. And if we, for example, try to call the code function, and if we run the program, here we have the default value. I'm a developer from our parent class here. And now if you, for example, want to re-implement or reassign the value, my profession equal to, we cannot because it's not annotated with open. So I'm going to make it open variable or open val to be able to override it. So here I'm just going to say I am an Android developer, and we're going to leave everything as it is in the main function, and we're going to run the program. We are going to see that I am an Android developer. Now, same thing with the abstraction or abstract keyword. You don't have to add the default value, just going to delete it, and in the Android you have to implement it, and also in the iOS you have to implement it. For now we all know all of this. Now we reach to our visibility modifiers. So the visibility modifiers, we're going to start first. There are three for inheritance and abstraction. There are three. We have another one, but it's not very important for us right now. So we're going to start with the private keyword. So now we're going to type private, and whenever we go to our Android developer here, we're going to find that we have an error saying that my profession is private. We cannot access it, so we're going to delete it here, and still here we cannot access it, so it's not even visible in the suggestions, so we cannot access the my profession here. As private makes the variable only available for accessibility within the same file or within the same class. So whenever you want to access this, you're only able to access it within the same class here. So for example, I'm just going to make fun, print my profession, and here I'm going to just say print ln my profession. So here we have access to it, but in our subclasses or child classes, we don't have access to my profession. That's cool. So this what the private modifier does. And now let's head to the second one, which is the protected. So protected means that this profession or this variable here is only be available for our subclasses. So say for instance, I want to access it here. We are able to access my profession. We're also able to access it here if we annotate it with the open. If we want to open, now we can override it as well. So my profession, we can override it and give it any value. But when we go to our class here, so say for example, I want to access my profession from Android dev, so my profession is not visible. Only the print my profession is visible, the function here. And my profession is not visible because we have annotated it with protected keyword. So protected keyword or protected visibility modifier just allows this variable, or if it was for a function, to be only accessible for our subclass or a child class. That's cool. So we said that we have override it here in our Android developer class. I am an Android developer. And now whenever we go to print the profession, we are able to get the value from our Android developer. I'm an Android developer. Though we weren't able to access it directly. So you have to add something a helper function. So this is a helper function that give us the ability to access the value of my profession, which was annotated with the protected keyword. That's cool. The last thing is going to be about the public. And public is very easy, as any function or any variable that wasn't annotated with anything, it's considered to be a public. So this guy here is a public, and we can access it from anywhere in my profession. See, it's public. It's by default, it's public. And if you add public, it's redundant. You can delete it, as anything by default is annotated with public keyword. Same thing with the functions. So print my profession here is public, and that's why we were able to access it from our instance here. So for instance, I'm just going to make it developer. I'm just going to make it protected. Now it's not public. We cannot access it. We're only able to access it within our subclasses like Android and so on, like here. So print my profession. Here we're able to do that, and to access it from our instance in the main function, we could call the open or the code. That's the code calls my profession, and my profession prints my profession, which is here. And if we run the program, we're going to have the same result as before. Similarly with other visibility modifiers as well, like the private. So this is private here, and now whenever we go to our Android dev, we're going to have an error saying that it's only private and it's only accessible within the same class that created it. So if you want to access it, for example, I'm just going to call it here, print my profession within the same class as it was annotated with the private visibility modifier. Before we end the video, let's have a little summary to clean up the confusion about open, abstract, inheritance, and abstraction in general. So whenever you have a regular class function attributes, you just have them as a concrete implementation. You don't let them be extendable to any other class. You don't let any other class to change this behavior of your attributes, attributes, function, or classes. For the open keyword, so whenever you annotate your classes, functions, attributes as open, you should provide your own implementation in the parent class, and you also provide them to be optionally extendable to any other class or subclass to provide their own implementation if they want to, or just pair with the default implementation in the parent class. Lastly, for abstract, so mark your classes, functions, attributes with abstract to leave the implementation for them to a child or a subclass. So whenever you don't want to provide the implementation, you just mark them with abstract and leave the implementation for a subclass or as a base class to give them the ability to build upon this abstraction. So that was it for today's video. I hope I didn't confuse any one of you, and please stay tuned for the next videos. We are about to finish this playlist, but we have some couple of stuff to talk about that are related to classes. Thanks for watching, and see you in the next one.